Okay. So here we are. So instead of writing f capital F prime equals little f, that's a derivative formula. We can write the integral of little f is big F plus this c. That c is called the constant of integration. We always have to worry about it. So, for example, we know that the derivative of x to the n is n to x n minus 1. Okay, that's our good old power rule. That's one of the first things that people see, and they always like that. Okay, so that means that the integral of n x to the n minus 1 dx equals x to the n plus c. Okay, now integrals are a linear thing, right? The integral of a constant times a function is a constant times the integral of the function. That's true because the derivative, since it's true for derivatives, it's also true for antiderivatives. So that means we can take this n and we can divide it through. We can divide this by n, but since it was an arbitrary constant, it's still going to be an arbitrary constant. And if this was n here, what do we see that antiderivative does? We see that it adds 1 to the power and you divide by that power. So this is going to be, so the integral of x squared dx is x cubed on 3, x cubed dx, x to the 4th on 4, x to the 4th, x to the 5th on 5. So when we take the antiderivative of any power, we add 1 to the power and we divide through by that power there. So this is the power rule for antiderivatives. Notice it's not going to work when n is minus 1, right? Because there was no way that we could get an x to the minus 1 as a derivative, right? Because the derivative of x to the 0 is just 0. So we can't have that. But we're saved because we do know what thing gives us a derivative of 1 on x, and that's ln of x. We know that the derivative of ln of x is 1 on x. So that means the integral of 1 on x is ln of x plus our c. We know that the derivative of k times x is just k. So that means the integral of k is just kx plus c. So And then finally, we know that the derivative of e to the kx is k times e to the kx. So that means the integral of k e to the kx is e to the kx plus c. And again, we can divide by k to get the exponential rule. Just let you digest that for a second.
Can you explain the E function again?
Sorry?
Can you explain the E function
Which bit? This bit or this bit?
again? The right side.
This one?
Yeah,
Oh, okay.
and I can use that.
So the main thing is antiderivatives is taking the inverse of derivatives. So whenever in a derivative you will multiply with an antiderivative, you divide. So remember, when you took the derivative of e to the kx, you would multiply by k. So that means whenever you take the antiderivative, you should divide by k. And that can be seen in the following thing, right? Because if this is true, this means that the antiderivative of k e to the kx is e to the kx of some constant. That's just the same, that's just stating the same thing as here. Okay? But we want a formula for the antiderivative of e to the kx. So that means we've got to divide everything by k. And if we divide by k, here we get integral of e to the kx. Here we get e to the kx divided by k. To our constant. So the basic idea is where before you multiplied by something, here you would divide for it. When you would take 1 from the power, now you add 1 to the power. So you always do the opposite of what you did when you did a derivative. Okay, and so this is an important thing to note. This is how we treat sums and constant multiples. All right, so this is just completely restating derivative laws. So we know that the derivative of a sum is the sum of the antiderivatives. Okay, and so this tells us straight away then that the integral of a sum is going to be the integral the sum of the integrals. And also, since the derivative of a product is equal to the product of the derivatives, it's also going to be the case that the integral of a constant multiple is a constant multiple of the inverse. So that allows us to do things like this, because we can just break it up. Okay, so if I was to do the intermediate steps, if we had the integral of 3x plus x squared dx, I can write that as the integral of 3x, the integral of x squared dx, it's going to be 3 times the integral of x dx. Okay, and so now I can just do all the things, right? The antiderivative of x is I add 1 to the power and divide by that power. Right, so the antiderivative of x is x squared on 2. So I can replace that by x squared on 2. The antiderivative of x squared is x to the cubed on 3. So I can replace that by x cubed on 3. And so I just plug those in. And then at the end, I do the plus c, because if I differentiate, away goes that constant. And so the answer is going to be 3x squared on 2. So I have to warn you that doing this, antiderivatives is the opposite of derivatives, so it's harder. Because typically with derivatives, you have a whole bunch of rules and you just apply the rules. To take the antiderivative, you've got to kind of work backwards. So sometimes you have to figure out, well, what's going to give me, when I take the derivative, what's going to give me that function there? And so you've got to think of that original function, and the rules aren't so clear for doing antiderivatives as doing for derivatives. Because you know, with things like derivatives, you've got like the product rule and the chain rule and the quotient rule. Like undoing those rules can be quite complicated. So you can differentiate anything, but sometimes you can get some antiderivatives which are just too complicated to figure out. It's not, the rules aren't as straightforward. So for example, there's not a product rule for antiderivatives, right? Because the derivative of a product is that, you know, f prime times g plus g times f. So that means to undo the product rule, you have to see, can I recognize this as an f prime times g plus a g prime times f? If you just think about it, you can think, that's going to be really hard. And it is, and it can be. But we have to do with what we can do. We have to live with what we can do. Okay, so here's some more examples. So in a lot of cases, you can just sometimes turn the crank. So with a derivative, you can always just turn the crank and spit out the answer. You just apply the rule, do enough work, and you'll get the answer. You can't always do that with input. But with these ones you can because they're pretty straightforward. Okay. So we're going to find the antiderivative 8x cubed plus 1 on x. Right, so it's going to be 8 times the antiderivative of x cubed plus the antiderivative of 1 on x. Now the antiderivative of x cubed is x to the 4 from 4. Right? And so we're going to multiply that by 8. And that's going to get us 2x to the 4th. The antiderivative of 1 on x is ln of x. So, and that's just added to that. So we just add those two things together. So we get 2x to the 4th plus ln of x. And then at the end, we just add in the plus c.
You have to have the absolute value on the x.
Yes, because remember ln, just remind you what ln looks like. Oh, what 1 on x looks like this, right? That's a hyperbola. So at any point it's got it's got a slope, right? So here the slope here is ln of x. If we're over here, say at x equals -2, the slope is ln of 2 because it kind of mirrors the situation over here. And so you have to use the absolute value sign whenever your x can be negative. But if you're dealing with cases where your x is never negative, then you don't have to worry about it. So the answer is try and remember to put it in, but I'm not going to dock marks if you don't put it in. The only case where you really need it is it going to be a case when you're going to put in a negative value, and then when you put in a negative value, it's going to be undefined, and then you're going to go, oh, I've got to change that to a plus. So you should do it, but it's not that important unless you're actually doing something, in which case you'll notice that it's wrong. Okay, and also with the plus c's, if you forget to put the plus c here, that's okay. I just want to see the plus c at the end. So typically what I do is I do the question, and then at the end I say, oh yeah, plus c. Again, it hardly ever matters unless it does matter, in which case it's going to be obvious. So for example, when is it important? You have a question like this. What is the antiderivative of x squared for which what is the antiderivative? Let's call it f, for which f of 1 equals 2, or equals, let's say, 4. Okay, so you take the antiderivative of x squared, get 2x. So I'm deliberately forgetting the c here. And I need f of 1 to equal 4. Well, 2 times 1 equals 2. Ah, and then you say, oh yes, now I remember. I have to put in the plus c, and then you have 2 times 1 plus c, and you want that to equal 4, so that means c has to equal 2. So the answer is 2x. So again, And this is in a situation like this, you need that +2 to be able to finish off the question. So then let's do another one. Antiderivative of 12e to the 0.2t. Okay, so we can pull out the 12, and then we want to take the antiderivative of e to the 0.2t. Antiderivative of e to the 0.2t is e to the 0.2t, right? Because the derivative of an exponential is always an exponential, that means the antiderivative of an exponential is always an exponential. Okay? But with derivatives, you multiply by the constant. With antiderivatives, you divide by the constant. So you divide by 0.2. Dividing by 0.2 is the same as multiplying by 5. So you end up with 60 times e to the 0.2t. And then you add it, and then you remember to put in the +7. Okay, now this always causes people grief. There's always someone messes this up. Let's think of trig functions. Now, we know that the derivative of sine is cosine, and the derivative of cosine is minus sine. Check. You will remember this? So that means the antiderivative of cosine is sine. And the antiderivative of minus sine is cosine. So that means the antiderivative of sine is minus cosine. So the antiderivative of cosine is sine. The antiderivative of sine is minus cosine. So people always screw up the signs, the plus or minus. Right? When you take the derivative of cos, you get minus sine. When you take the antiderivative of cos, you get plus sine. When you take the derivative of sine, you get plus cos. When you take the antiderivative of sine, you get minus cosine. Okay? There's always someone who misses that up. So don't let that be you. My word of advice. And if we had cosine of kx or sine of kx, remember when we take the derivative, we multiply by the k. Now when we take the antiderivative, we divide by the k. So the antiderivative of cosine of kx is sine of kx divided by k. And the antiderivative of sine of kx is minus cosine of kx divided by k. So you just got to remember when you're taking antiderivatives, you do things backwards. Right? You divide, you don't multiply, you add powers, you don't subtract powers. Cosine and sines get swapped around, which one becomes negative. So everything just gets reversed. Okay, so, but this is good because now we can take antiderivatives of quite complicated things. So for example, the antiderivative of sine plus 3 cosine 5x. Again, you've got that linearity property, which makes it easy to break up the antiderivative, right? So we break this up into the antiderivative of sine plus 3 times the antiderivative of cosine 5x. The antiderivative of sine is minus cosine. The antiderivative of cosine is sine. So the 5x stays there, and now we divide by 5. And so since we had a 3 here, we get 3/5. And then at the end, we remember to put the plus c. And the thing is, you can always double check your answer by differentiating. If you're unsure whether you've done the right thing, just differentiate, right? The derivative of minus cosine is sine. The derivative of 3/5 sine 5x, right, is 5 cosine 5x times 3/5. So the 5 times the 3/5 gives you the 3, and the sine gets turned into the cosine. And then when you differentiate the plus c, that goes away. So we double checked, and so we know we've got the right answer. Okay. Which of the following is an antiderivative of x squared plus 7? Have a think of that. Usually we've got Eric here to yell out the answer, so you have to rely on one of you two. What do you think? A. So the antiderivative of x cubed is x cubed on 3, so that's correct. But what's the antiderivative of 7? No, because when we differentiate gives us 7. What has a slope of 7? Right? The 7x, the derivative of 7x is 7, because 7x has a slope of 7 everywhere. So this is saying what has a slope of 7 everywhere? It's 7x. And remember, I'm asking for an antiderivative. I'm not asking for the antiderivative. So it doesn't have to be plus c. It can be plus 7, for instance. Let's have a look at this. What's the derivative of this? Down comes a 3. You subtract the power. So that becomes x squared. The derivative of this is 7. The derivative of this is 0. X squared plus 7. So this C was the answer. Okay? Kind of convinced? Okay. We're just starting out here, so it's okay to not grapple it forward. Which of the following is an antiderivative of 1 over 2t? antiderivative. So this is, so let's go through them one by one. Let's just figure out what the. So we want to have the antiderivative, so that means we want to take derivatives. Right? So what is the derivative of -2 over t squared? -2t to -2. How do we take the derivative? What do we do to the power? We bring it down, so it becomes 4, right? Because -2 times -2. And then we subtract 1 from the power and get t to the -3. Okay. That's not going to work. What about 2 ln of t? What's the derivative of ln of t? Or 1 over t, because t is our variable, right? So the 2 stays on top. 2 is not on top here. So this doesn't work. Ln of 2t. Well, this is going to equal ln of 2 plus ln of t by the log laws. And so when we take the derivative of this, this is going to be 0 and 1t. So this doesn't work. Okay. Well, this A better work, or else the answer is B. So 1/2 ln of t. It's going to be 1/2, and the derivative of ln of t. That's 1 over 2t is 2t to the minus. That one works. Okay. Well, that was a little bit of a tricky one because we had to do some stuff with log laws and things. So. Okay, so this is going to be a little bit of a memory test for you. Antiderivative of 6 sine 3x. Okay. Why is B and C wrong?
It's not cosine.
Yeah, it's not cosine. We know that the antiderivative is right. Okay. So why is E wrong? It's not negative, right? Because sine goes to negative cosine. So it has to be either A or D. It is, yes. Because we divide by the 3. When we differentiate, we multiply by the 3. When we do antiderivative, we divide by the 3. The D, so everyone looks much more comfortable with that one. Okay, good. We're getting there. Okay, so if we know that the antiderivative of f of t is 2 cosine t plus c, what's the antiderivative of 2 times ft? What do you think? So what's the difference between these two things? We're just multiplying by 2. So we're taking the antiderivative of 2 times something, but that's just the same thing as 2 times the antiderivative. Okay, so which one of these is 2 times that? D is right. Yeah. Actually, also C would have been right too, sort of. Right? Because C is arbitrary. And if we double an arbitrary number, we're still left with an arbitrary number. So, this is like 100% correct. This is 99% correct. So again, terrible test question. Just illustrating the point. Okay. What about this one? What would be the antiderivative of negative g? Again, what's the difference between these two things? Just the negative. So the antiderivative of negative something is negative the antiderivative. So the answer is E. Exactly right. So again, this would be 100% correct. This would be 99% correct. And this would be like 50% correct. The others would be totally wrong. Okay, oh, here's a harder one. We're just building up. What's the antiderivative of 2 times f minus g? Yep. Right, because the antiderivative of 2 times f minus g is 2 times the antiderivative of f minus the antiderivative of g. Here's the antiderivative of f, here's the antiderivative of g. So we do 2 times this minus that. Quite definitely we get that. Okay. So again, this would be 100% correct, and this would be 50% correct. Everything else would be totally wrong. Okay, so that's what we learned today. So I got some homework questions for you. So I think the best thing to do is just do some homework questions. And so that's the main thing. It's the whole idea of the definite integral is just undoing, it's just doing the reverse process of differentiation. And so since you know how to differentiate, in theory, you know how to do anti-differentiation. Okay. And so we'll meet on Monday and we'll continue going this. And so I think next week we'll finish off chapter 6.
Next week we're meeting Tuesday.
Oh, sorry.
Are we meeting Tuesday next week since we're off on Monday? Are we meeting Tuesday next week? Since
Yes,
we're off
yes.
on Monday?
Yes, because Monday is a holiday, isn't it? It's
Yeah.
Easter.
Yeah.
Great. You doing anything?
We're having Easter at my house in London, so.
Great. You doing like a lamb, ham, or
Ham.
Ham.
Yeah.
My wife likes saying, I come from Australia. We love lamb. So we always do lamb at Easter. So we're having lamb for Easter. I love lamb. It's harder to get here. See you guys. See you Tuesday.